This is Geometry Chapter 14, Lesson 1 on page 572. All right, we're talking about regular polygons in this chapter. All right, so what makes any polygon regular? Does anybody remember what regular means? We've talked about this.
If it's equilateral and equiangular.
Equilateral and equiangular, right? There's only one shape that is always ever regular. Can you think of it? Which one?
Square.
A square is always ever regular, right? We can have any other polygon. It can not be regular or it can be regular. All right, so look at the different polygons on the top of page 573. An equilateral triangle. We know in an equilateral triangle, the measure of every angle. What's the measure of every angle in an equilateral triangle?
60 degrees.
60 degrees. 180 divided by 3, right? We know that the square is the only regular quadrilateral. It's the only regular quadrilateral. All right, now look at the regular pentagon. How many sides does a pentagon have? How many sides does a pentagon have? I know, Miss Van Valkenburg. I taught her boy. How many sides? A pentagon. Come on. 5. If a pentagon is regular, then what is going to be the measure of every angle? All right, so let's back up. What is the measure of the sum of all the angles of a pentagon? Do you remember how we get from a quadrilateral to a pentagon? And then from a pentagon to a hexagon?
Plus 180.
Plus 180 every time. Plus 180, all right? So take your quadrilateral, add 180 to it. What do we get? Say it.
540.
540. What's 540 divided by? How many angles does a pentagon have? 5. So notice always when we're talking about the number of sides, the number of sides of the vertices of all of these polygons are going to equal. All right, so what's 540 divided by 5?
108.
108, right? All right, the next one is a hexagon. Hexagon looks like what shape you see every day? Stop sign. Okay, hexagon has some very interesting measurements that is not necessarily true of any other regular polygon. All right, so I'm going to draw a hexagon. All right, if that is the center of the hexagon, just like circles have radii, so do polygons. All right, so if I go from the center of that hexagon to a vertex, that's called a radius. All right. So now with 2 radii, that would give me that angle, right? But we've been talking about this angle. So what would be the sum of these interior angles of a hexagon? What's the sum of these interior angles? I'm going to label it interior angle. All right, so if a pentagon is 540, then a hexagon is? Come on. Do that mental math quickly. 720, right? So the sum of the interior angles has to equal 720 degrees. So what is one of those angles then? 720 divided by 6 is
120.
100 what?
20.
120? 120 degrees. So this is going to be 120 degrees. All right, what is this angle going to be? And how many of, all right, let's draw every radii. That's 120. All right, all the way around is how many degrees? 360. All right, so how would I get this one angle theta here? How would I get that angle? 360 divided by 6. That is correct. Because all of these have to be equal because it's regular. It's a regular polygon. All right, so this is going to be 60 degrees, right? All right, let me label some points. A, we'll call the center B, C. Do you see triangle ABC? All right, so the radii actually divide a regular polygon, particularly a hexagon, which is different from all the other ones, into unique types of triangles. All right, we know that is 60 degrees. What do we know about AB and BC? What must be true about AB and BC? Since they're radii, what must be true? They have to be equal. All right, so AB has to equal BC. Therefore, what do we know about angle BAC and angle BCA? Why do they have to be equal?
Because the opposing sides are equal.
Correct. When opposite sides of a triangle are equal, the angles are equal as well, right? So we know that this angle has to equal that angle. You agree? Well, can we figure out the measures of those angles? We can? All right, so how? How do we figure it out?
Subtract 60 from 180 and then divide what's left by 2. And so both of those would be 60.
Both of these are 60 as well. So the radii of a hexagon form what types of triangles? 100% of the time, if it's regular. Equilateral triangles. Okay, let's lock that in our brains. The radii of hexagon divide our hexagon into equilateral triangles, all congruent to each other. This triangle is congruent to that triangle, congruent to that one, to that one, to that one, to that one. Got it? Such that it's only true with the regular hexagon. Only true with the regular hexagon. Got it? Equilateral triangles. All right, so if I tell you that's a radii, and I tell you the length of that radii is 6, could you give me the perimeter of that hexagon? How would we get the perimeter?
Well, if the radii is 6, then the side has to be 6 because the angles are equal, so the sides are equal.
That is exactly right. So every side has to be 6. So given a radii of a regular hexagon, you should be able to tell me what the perimeter is. Now there's something else unique about a hexagon. So this will be a new word. Let me draw another one. All right, we know it's equilateral. We know every angle, I'm gonna label this one here, is 60 degrees. Now what if I draw a line from the center perpendicular to the other side? What do I know happens to this side? It bisects it, that's correct. So this line here is called an apothem. Every polygon has apothems. It's a line segment from the center of a polygon perpendicular to the side. But since we have at least an isosceles triangle, we know it divides it, the opposite side, into equal parts. So that if the entire length was 6, you'd know that that is 3 and that is 3. Right? You with me? You hanging with me? Okay. Now I know that this angle is 60. So what must this angle here be? 30. What type of triangle does the apothem divide a regular hexagon into?
Right.
What kind of right?
30, 60, 90.
It's a 30, 60, 90. What's the Pythagorean triplet for a 30, 60, 90? Okay, I'll give you the first number. 1.
Square root of 3, 2.
Wait. Square root of what?
3.
Square root of 3, 2. 1, square root of 3, 2. 1, square root of 3, 2. 30, 60, 90. Okay, so now we have 3, which is opposite to 30. Could I then calculate the length of the apothem and the length of a radius? Okay, I'm going to change the numbers because we already know the radius is 6. Wouldn't that be true for this triangle? Right? Because the side opposite 90, when we go from the 30 to 90, we double it, right? 30 to 90 is 1 to 2, so we double it. Going back 90 to 30, we take half of it. Remember, we always want to go up to opposite 30. All right, so then if I change this, instead of being, we'll just make it, I'm not going to give you that. I'm just going to give you the length of this side. Opposite, we'll say it is 7. All right, so if the length opposite 30 is 7, then what's the length of my apothem? How do I get opposite 30 to opposite 60? Opposite 30 to opposite 60. Somebody knows. Come on. What's the answer? If opposite 30 is 60, what's opposite 60, which will give me the measure, the length of my...
Would it be opposite 37?
Is 7, yes. So what is the length opposite 60?
7 square root of 3
How'd you get there?
by multiplying square root of 3.
Correct. These are the Pythagorean triplets. We must know. This is what's on the unit circle. When we get to trig, you have to have this memorized, right? 1, square root of 3, 2. To get opposite 30 to opposite 60, we multiply by square root of 3. Now, how do I get opposite 30 to opposite the 90?
Multiply by 2.
So what is it, Allie?
14.
14. All right, so these facts are true about every regular hexagon. The apothem divides the apothem and a radius, gives us a 30, 60, 90 triangle. 2 radii give us an equilateral, equiangular triangle. All right? And we can always calculate a radii, a side, or the length of the apothem. Regular hexagons are what I see oftentimes on the ACT. And it's something simple like this is 14. A radius is 14. What is the perimeter? Well, now you're going to tell your brain, it's a regular hexagon, right? And the length of a side equals the length of the radius, so I'm going to multiply the radius times 6. Right? All right, so that's a regular hexagon. Lots of great information with the regular hexagon. We also have regular heptagons. That's 7. You're going to have to know these shapes. We have regular octagons. We have regular nonagons and regular decagons. If we have a regular polygon, it is cyclic. What does cyclic mean?
The vertices lie on the circle.
Correct. There is a circle that I can circumscribe about it such that every vertex would lie on that circle. So if I have a regular polygon, which means equilateral, equiangular, then I can graph a circle about it. All right, we've talked about the radius from the center to a vertex. We've talked, well, about the center. We've talked about an apothem. This angle is called a central angle. That 60-degree angle is called a central angle. All right, so if we had an octagon, let's just look at an octagon that has 8 sides. Okay, I have to look at it to make sure I draw it. Okay. So it has 1, 1, 2. That's gonna be too fat, huh? 1, 1, 2. Okay, just go with me on this. Maybe. Doesn't look very regular. All right, but we're gonna call that a regular octagon. This is an interior angle. Remember, here is an exterior angle. Do you remember those? It forms a linear pair. And do you remember that if I added all of the exterior angles going around, we'll call that H. If I added all those angles going around, all the exterior angles, the sum would be 360. Doesn't matter how many sides there are. The sum would be 360. All right, so the sum of exterior angles of any polygon, it doesn't have to be regular, any polygon is going to equal 360 degrees. The sum of the exterior angles going around. Okay, so this is an octagon. What would be the sum of the angles of an octagon? Okay, we said a hexagon was 720, right? So a heptagon was 720 and 180. $720 and 180. 900, right? So this one, an octagon would be 1080, right? All right, so the sum of the interior angles is 1080. What would one of the interior angles be? It would be 1080 divided by 8, because there are 8 angles, 8 sides, 8 angles. Vertices equals the number of sides. So what, that's 1, leaving me 28. 3, 135 degrees. Did I do that right? So an interior angle would be 135 degrees. This would be a central angle. What would be the measure of a central angle for an octagon? And how would I figure that out? Well, how many central angles do we have in an octagon? Remember, they're all going to be equal. There's 2, 3, 4, 5, 6, 7, 8. 8. 8 sides, 8 central angles, 8 interior angles, 8 exterior angles. You got it? They're all 8s. So to get one central angle, I take the 360 divided by 8. What is 360 divided by 8? 40. Is it 45? be 32. It is 45 degrees. All right, so all of these angles would be 45 degrees. And then we would know these other two would have to be divided evenly between 180 minus 45, which is 135. So what is that? 62, 67.5, something like that. So 45 degrees would be the central angle. If I drew an apothem, it would divide that side evenly. It would bisect it. And it would also bisect that angle. All the apothems on regular triangles bisect the angle between the apothem and the radii. So if the whole angle is 45, then the bisected angle is 22.5. Does that make sense? So this would have to be 22.5 degrees. So sides are bisected, angles are bisected when we construct or draw an apothem. You got it?